I received several comments from my previous videos asking to show how to implement WalletConnect with Metamask and other providers um, within a real-life React built application. And so in this video, we're going to build something that you guys can then take and use as a foundation for your Web3 app. We'll implement the authentication with Metamask, Coinbase Wallet, and WalletConnect protocols. And then we'll go as far as connecting our app into connecting the app with a smart contract. As far as the tech stack, I'll be using Next.js, Ethers.js, and Tailwind CSS. You can, of course, use any of the alternatives. I don't think your implementation is going to deviate too much. If you're new to this channel, welcome. Here in Gasford, we practice building decentralized Web3 applications on the Ethereum blockchain. If you don't want to miss my future videos, make sure to subscribe and hit that notification bell. All right, so let's get started by creating a new Next.js app. We'll run yarn create next app. And we'll name it auth web3. So let's run this by running yarn dev and opening localhost port 3000. And we see a boilerplate welcome screen from Next.js. Now, before we get rid of this and start building our authentication, we also need to set up Tailwind CSS. They have a guide specifically for Next, so you can just copy paste the commands. So let's test if we have Tailwind. It looks like we do, but let's just verify by adding. Yep. Okay, so that's done. Now we can remove everything from this page inside our main tag. You can also remove the home module CSS. Since we're not going to be writing our own CSS, we'll just use Tailwind's utility classes. Okay. Cool. Now, what we're going to need next is we're going to need a button that says connect wallet or authenticate. So let's create, I'm going to go ahead and create a component for that. And then we'll also manage our state with Redux.js and use an async thunk to reflect whatever happens after the wallet has been successfully connected. So for for Redux to successfully propagate our state down the components tree, we need to wrap our main component inside a provider component that we get from the Redux library. So let's go ahead and do that. In Next.js is going to be _app.js, which renders your main component. So we just need to import our provider and store which we'll create in a bit. We can create it app store.js, and I'm just going to copy paste as the store structure for our application. These are the reducers that we will need to implement later, so I'm just going to comment them out. And this will also be empty for now. And then here we can just and so for every provider option here, I'm going to use not to duplicate the styling and the markup. I'm going to use a styled component here so that we can extract it as a separate component, and then we can make edits to that one place we want to change it in it. So let's go ahead and install the styled component first. And then here we need to import and we can then declare a wallet list item as a list item tag, and then pass in some custom class name. Yeah, this is better. All right, let's dive into that Metamask implementation. All right, so now, given we have the Metamask browser extension installed, when we click login, it offers to pick a wallet provider. Once we click on Metamask, it will connect to our Metamask wallet. Let me disconnect here to demonstrate. Oops, there seems to be an error in our format address. Okay. So Metamask brings up Metamask. I pick the wallet I want to connect. Next, connect. And then after I see the wallet that I've just selected. This is the wallet that I'm now connected with to this web page. And then also, let's see if we have our, so we could also populate our balance and show how much ETH we have in the wallet that we connected. Let's do that. So now after we connect our wallet, it will also show the balance right next to the wallet address. And as you can see, our account object has our provider. It shows whether it's connected or not. It shows the network ID. And in fact, the network ID here has to be Rinkaby. So let's switch the network, since we're going to be operating on a test net for now. Yep. So that is correct. And let me start from the beginning and explain how this whole connect thing works with MetaMask for now. So here in our index page, we have an account selector, which grabs the account part of our state. So if you go to store.js, it's this thing, which is then defined by the account reducer. And the account reducer is something that we import, something that's exported from account slice. And this is the default export of account slice. And this is where we define the internal structure of that account object. What's most important here and what's being called, if we go back to our Connect wallet, so we use this account here. And what we check if the wallet has been connected. And if not, we show the connect wallet component. So if we go to this component here, all it does is it renders a details tag with a summary button. If we click on that summary button, it will just show a drop down of various wallet provider options, like we see here. And then once you click on any of those, it will invoke the on-wallet list item click function, passing in the type of the wallet that you chose. And this one here is going to dispatch a connect account thunk and close our dropdown. So let's see what this one here does. Connect account is also something that we import. We don't need these. Something that we import from our account slice. So if you click on it here, so the connect account thunk, once it's invoked, it will basically execute this async function where it fetches the Infura ID, chain ID, network name, anything it needs to properly identify the blockchain network that it needs to connect to. And then afterwards, we've also added this handy function here where it just, depending on the wallet type, it will return a provider object to use for the WalletConnect functionality. Here we have MetaMask. It will just return the injected Ethereum object. This one here. And in case we select any other like WalletConnect or Coinbase, it will use their own third-party plugins and then eventually return a provider object. So the API might differ between these two, but at the end, it should return a provider object, either for WalletConnect or Coinbase. After we have a provider, we will use that to initialize an Ethers provider, Web3 provider instance. So you have the provider, then you pass in that provider into another function that's called connect wallet, which is going to return a promise here that grabs your accounts list from, in this case in MetaMask, it will just grab an array of, I do have one account, so we'll just have an array of one account address. In case of a success, it will get the signer from the provider, which means that if there's a signer in the provider object, it means that you have successfully connected your wallet and Ethers can now act on behalf of that wallet. So then we want to resolve our promise with our first account address. So after connecting, after calling the connect wallet, it will grab that address, it will assign it to these variables, and then it will basically dispatch our connected action with all these variables and objects that afterwards will get assigned to our state.account slice. So on a successful connection, this here will get updated from false to true. This button should disappear, and then our current account balance and our address should show up instead. So let's try that again and see how it works. And there we go. So MetaMask is all great, but what about other wallet types? What if I have my Coinbase wallet, or what if I have a Rainbow app on my iPhone and I want to use that? All right, now that we have our little inconvenience resolved, we can then see how selecting WalletConnect will show up the WalletConnect model dialog that says scan the QR code with your WalletConnect compatible application. I'm going to test the Rainbow app for iOS and see what shows. So after I confirm that I want to connect on my phone in Rainbow, it will automatically connect inside our app, and it will also show the wallet address here as well as the balance, and you can see that it's not the same account we connected with in MetaMask. And same thing works for Coinbase. You click on the Coinbase option, and then depending on whether you have your Coinbase browser extension installed or not, you can use your browser extension, or you can use the Coinbase app again on your phone. Same thing applies there. You just need to scan this QR code over here, and then after you confirm, you will be connected to your Coinbase wallet inside this application. And here you might actually want to let's try sending some ETH, some Rinkeby faucet ETH, and I believe there is some formatting that has to be done here. This is not the most user-friendly way to show the balance, so let's fix that real quick by using a utility method from Ethers. All right, so now that we show the actual ETH inside the wallet, I wonder if you can exchange your ETH to USDT on Rinkeby. Okay, so we're gonna try to swap 0.03 ETH to USDT. This looks a little odd, but let's try anyway. Okay, now in our wallet, we not only have some ETH, we also have an ERC20 token. Doesn't really matter what the token is, as long as it conforms to the ERC20 format, it should be okay. This here says compound USDT. I'm going to assume it's some Rinkeby testnet alternative to USDT, which is fine for now. And so what I want to do here is I want to show not only the ETH balance, but also how much ERC20 USDT or compound USDT we have. And that's gonna require interacting with a smart contract, which is exactly what I wanted to demonstrate after we implemented connecting wallets. Now, the contract here, as you can see from the transaction, where we see compound USDT, it is these 0x5662E compound USDT contract. And so we can read the value of the balance of function that takes the address and then returns the amount of the token of this particular token for that address. So let's replicate this exact functionality. Let's actually change the UI a little bit so it's not all concentrated in this corner. We could say and then we want to show the USDT balance, which we should fetch before this. So let us change our account slice here. Like this. We might also need the USDT contract address, which is this over here. Let's get rid. Well, this should be fine. We want to assign it to our config state. And then after we get our signer, we get our account wallet address, we can initiate a contract. Ether.js has this handy function that's called Human Readable API. And it's something that I want to use here as well. So we're going to need, yeah. So it allows you, instead of copy pasting all that JSON, it allows you to cherry pick the methods that you will be using. So you don't really have to copy paste the entire API, and you don't have to do that in that JSON format. That's not very user friendly. You can just practically just grab the Solidity method definition over here. So you know what the method name is, the arguments that it takes, the type of the method, whatever it returns, the type of the return value. So pass that in as an array. And that should be it. So now we can grab our USDT balance like so. Now let's reconnect our wallet. Is this the right contract address? Yeah, I think this should be the contract address. So now we get our crazy long USDT balance. Let's format that as well. Well, we are formatting it, aren't we? Okay. So now we have our properly formatted ETH and USDT values. This one we're getting the moment we connect our account. And for this, we are pinging the USDT contract on the Rinkeby network over here, calling the balance of function, passing in our wallet address that we just connected, and then outputting the value that we get in return. And if we were to connect another wallet that does not have any ETH or USDT, it should then be all 0, like here. So you can then take this code base if you want to build anything based on Next.js and React. Let's say you're building a Web3 minting web page for your NFT collection, or you're building a DeFi decentralized application. You can use this as a foundation of Web3 wallet authentication, state management, configuration management with some network or chain specific configuration, and then grow this into a sophisticated and hopefully very awesome decentralized app. Leave your comments below if you have any questions. I'll put the link to the source code in the description, and I will see you in the next one.